what's really important is understanding how to get the A and B terms, okay, because that allows us to get our proportions for our asymptotes, which then allows us to draw the graphs. Not only that, those A and B's also allow us to locate our vertex. So we want to set this up into its graphing form. So we need to make this equal to 1. Now, we could make it equal to positive 1, but then we would have to flip them around. So it might be just easiest to leave the negative there. And I'm going to divide by 400. So that's going to simplify to x squared over 100 minus divide by 400 here. Okay, we have common factor of 25. That means that 25 goes into 400 16 times. Okay, so first things first, is this trans x or trans y? Okay, based on x squared minus y squared equals the negative, this is trans y. Okay, so I just want to make sure that I recognize that. It's going to be along here, trans y. I want to know my a value. So a squared is 100, so a is the square root of 100, which is 10. My b goes with my y. B is equal to 4. And that's really it. That's all the information I really need to be able to draw this. Because I can now then take my b value, locate my expansion along the y. Okay, I can take my a value and work out my expansion along the x. So what does that help me do? Well, if this was an ellipse, I would just draw my ellipse. But now what I'm going to do is just going to again locate these corners, because these corners help me draw my slopes. Okay, because this slope here of rise and run is the same as this rise and run here. So these points are key. I usually draw in the rectangle just as a frame of reference, but again, that's not super important. What's more important is that we get those corners, okay? Because those corners allow us then to draw, oops, I should draw this as an asymptote. It allows us to draw in our asymptotes. In fact, we know the slope of this asymptote is going to be the ratio of rise to run. Rise to run. I have to do that in the right colors. My rise of 4, my run of 10. Okay? And not only that, we have plus minus. Okay, so these are the equations of my asymptotes. So that's really all the work I have. Now the last thing is I just need to make sure that I draw along the right axis. So I don't want to draw along trans x. I'm going to draw it trans y. So I'm just going to follow the asymptotes, find the vertex, follow the asymptotes. Okay, so there it is. There's my graph. And it's a trans y graph with those asymptotes and those red vertices. Okay, so we can do the same thing here. Now it's important to recognize that this one here, this is getting a little bit more awkward because the numbers are not nice. And notice that the orientation is y squared minus x squared, not x squared minus y squared. Okay, so now if you want to change it up, you can. So there's a couple options here. You could make it x squared minus y squared, but then you would have to make that difference the opposite sign. Okay, so that's one way to do it. The other way is to just keep track of that fact that it's trans y. Okay, so that's the first thing I'm going to say is trans y. Okay, so I know it's going to be along this axis. I want to be able to put it in graphing form, so I need to divide by 4. Okay, now this is in its reciprocal form of what we really need. Okay, so as long as I understand that it's in this reciprocal form, I need what's in the denominator. I can identify my a and b by understanding that really I'm dealing with the reciprocal. I want the denominator, but the denominator would be the reciprocal of what that fraction is. So the a value then is going to be square root of 4 over 49, or 2 over 7. Same thing with the b. I want the reciprocal form to be able to get the expansion compression factor. So it's going to be 2 over 5. So square root of 4, square root of 25. So there it is. So I'm going to use those fractional values. Let's scale this a little bit differently so that we have the proper scaling. Okay, so let's say instead of negative 5, let's say that's negative 1. That's positive 1, and that's 1, and negative 1 there. So along the x-axis, it's going to be 2/7. So 2/7 probably maybe right about there and there. Okay, those would represent my vertices along the x. 2/5 along the y. 2/5 maybe right about there and there. A little bit longer along the y. And then I want my corners to be able to draw my asymptotes. Now I know the ratio of my slope. So my slope is going to be rise over run. Okay, so it's going to be 2/5 over compared to 2/7. Now if you simplify this ratio, the 2's cancel. We have 5 in the denominator. Denominator is numerator. So that's my slope. Okay, so this is the slope of this line. If I want to know the slope of those lines. Okay, so this is y equals 7 over 5x. And this is y equals positive 7 over 5x. Okay, and then since it's trans y, we'll draw that hyperbola along the y-axis. Okay, so again, hyperbolas only need to have a vertex and asymptotes to be able to get the right shape. So there it is.